Good afternoon. My name is Nicole Morris, and today's topic will be harmonious motion and the bridge between sound and color. In order to delve into our topic, we must properly understand the title. Harmonious motion is a phrase often used in physics to describe the motion of a wave. A wave is the transfer of energy through particles to get from point A to point B. The parts of the wave include the wavelength, which is the distance that a wave travels in a single revolution. Then you have the amplitude, which is the height of the wave, the crest, or the top of the wave, and the trough, the bottom of the wave. There are two different types of waves in general. There is longitudinal waves and transverse waves. Longitudinal waves are signified by the compressions that are experienced within the wave and how the particles clash and then move back to their original standpoint, meaning that the energy just merely passes through them. Then you have transverse waves, where the particles travel with the motion of the energy of the wave. This can be signified by a slinky. This is the longitudinal waves, and these are the transverse waves. Now, within that, sound waves are longitudinal and light waves are transverse. Now we can further delve into their differences. Sound waves spread easier than light waves as they bounce off of objects. And then sound waves are registered through our ears and then processed in the parietal or frontal lobe. And then you have light waves, which are more focused and are when light particles bounce off of certain objects to reflect certain colors. These are processed through our eyes and further delved into by our visual cortex and our thalamus, which are located towards the back of the brain. Now that we've looked at the differences between the two, let's look at the mathematical correlation. This is a chart of their wavelengths compared with the sound and the color. You have G, which starts off at a bright red, which is also around 392 hertz, and then you end with F sharp at a fuchsia color at 698 hertz. Sound the alarm, though. The reason why I sounded the alarm is this is one of the rare occasions where math is only practical in theory. This is caused in part by psychology and cognitive science. Psychology is the branch of science in which measures our emotions and how they have an effect on our behaviors. Cognitive science is the branch of psychology which measures how our childhood affects our adulthood decisions. Now, from the time we were small, we were conditioned, meaning that means other people of higher standpoints or a higher authority taught us to associate certain objects and certain sounds and certain colors with certain emotions. For instance, when a movie scene is sad, it often has purple and blue colors, which are darker, and a minor scale played behind it. Darker colors signify this. Now that we've talked about all of these different parts, now we must get down to the nit and grit of it, which is the purpose of this lecture. The purpose of this lecture is to demonstrate the relationship between sound and color and its applications in the real world, which is to increase the standard of living for those who are hearing and sight impaired. Thank you, and good night.